Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0010, refers to a malfunction in the variable timing control, VTC oil control solenoid valve in the 2006 to 2011 Honda Civic. This system plays a crucial role in controlling the variable valve timing, which optimizes engine performance, fuel efficiency, and emissions across varying driving conditions. The VTC oil control solenoid valve regulates the flow of oil to the VTC system, and if it malfunctions, it can lead to engine performance issues, increased emissions, and reduced fuel efficiency. You can typically find the VTC oil control solenoid valve located near the engine's camshaft, where it connects to the engine's oil supply. Proper functioning of this component is vital for the engine's operation, as it allows the variable valve timing to adjust according to engine speed and load, enhancing acceleration and efficiency. Addressing the P0010 code promptly is essential to maintain the vehicle's performance and avoid further complications. The DTC P0010 specifically concerns the VTC oil control solenoid valve, a vital component in managing the variable timing in the engine. The VTC system adjusts the timing of the intake valves, which helps improve the engine's overall performance by optimizing airflow. Located near the camshaft, the VTC oil control solenoid valve receives oil pressure from the engine and controls the timing by directing oil to the VTC actuator. If the solenoid valve is malfunctioning, it can lead to incorrect valve timing, resulting in poor engine performance and increased emissions. The potential for adverse effects increases based on driving conditions, potentially affecting fuel economy and power delivery. Therefore, understanding the function and location of this component helps in effectively diagnosing and resolving issues related to DTC P0010. Several potential causes can lead to the occurrence of DTC P0010. First and foremost, a faulty VTC oil control solenoid itself can directly trigger the code, as its primary function is to facilitate the adjustable timing of the engine's valves. Secondly, an open circuit in the wiring can prevent the solenoid from receiving the necessary signals to operate. This can happen due to wire damage or disconnection along the circuit. Additionally, poor connections at the terminals can significantly affect the performance of the solenoid. Corrosion, dirt, or a loose connection may lead to intermittent or complete failure of the solenoid's function, exacerbating the problem. Therefore, these common causes must be inspected thoroughly to ensure that accurate repairs can be made. The presence of DTC P0010 can manifest in various noticeable symptoms that may affect the driving experience of the Honda Civic. Reduced engine performance is a primary symptom, potentially resulting in sluggish acceleration or uneven engine running. Additionally, drivers may observe a drop in fuel efficiency as the engine may not be operating at its optimal timing, leading to excessive fuel consumption and decreased power output. Another critical symptom is the likelihood of increased emissions, as improper valve timing can lead to incomplete combustion, potentially triggering a check engine light. Beyond performance issues, the vehicle's overall reliability can also be at stake, emphasizing the importance of addressing this diagnostic trouble code at the earliest opportunity. Understanding these symptoms can assist vehicle owners in identifying problems before they escalate. The first step in troubleshooting DTC P0010 involves ensuring that the ignition switch is turned to the on, capital II position. Doing this activates the vehicle's electrical systems without starting the engine. It's vital to record all freeze data at this stage for further analysis, as freeze data provides information about engine conditions at the time the DTC was set. Additionally, reviewing the general troubleshooting information specific to this error code helps establish a systematic approach to diagnosing the issue. This can include checking for any previously recorded data or snapshots that may indicate patterns or recurring issues related to the VTC system. Taking these preliminary steps lays a vital foundation for the troubleshooting process that follows. In the second troubleshooting step, clearing the DTC involves using the Honda Diagnostic System, HDS, to reset the vehicle's onboard diagnostic system. The HDS is an advanced diagnostic tool that interacts directly with the vehicle's computer, allowing technicians to clear DTCs and reset any malfunction indicators related to the VTC system. This step is essential as it provides a clean slate for a subsequent diagnostic run. Once the DTC is cleared, any future occurrences can be monitored to determine if the underlying issue has been resolved or if the problem persists. Understanding that this reset procedure is part of good diagnostic practice will aid technicians in effectively managing DTCs and ensuring that repairs are targeted accurately. After clearing the DTC, the next step is to start the engine and hold the engine speed at 3,000 RPM without putting any load on it, such as in neutral. This step is crucial for ensuring that the engine operates under controlled conditions, thereby allowing technicians to assess the behavior of various components under specific situations. Holding the engine speed at this level enables the Engine Control Module, ECM, to engage the VTC system fully, which can help to identify whether the solenoid and associated systems are functioning correctly. It's essential to monitor when the radiator fan comes on during this process, as this indicates that the engine has reached a certain operating temperature. Such observations provide valuable insights into the real-time operation of the VTC system and help to differentiate between different possible issues. The fourth step in the troubleshooting process involves conducting a VTC test using the Honda Diagnostic System, HDS. This specialized test assesses the performance and functionality of the variable timing control system, providing detailed information on its operation. By executing this test, technicians can determine whether the VTC oil control solenoid is working correctly and if the system responds as expected under controlled conditions. After performing the test, it is crucial to check for pending or confirmed DTCs using the HDS. Any new or recurring DTCs will provide immediate insight into whether the troubleshooting process should proceed or if the system is functioning properly at that moment, enabling efficient and accurate diagnostic procedures. The fifth troubleshooting step is determining whether DTC P0010 is indicated after conducting the VTC test. If this code appears, it confirms that there is a persistent issue with the VTC oil control solenoid valve or its associated circuitry. Conversely, if DTC P0010 is not indicated, it suggests that the vehicle may have experienced an intermittent failure. In such cases, the next logical step would be to inspect for poor connections or loose terminals at both the VTC oil control solenoid valve and the engine control module, ECM. Ensuring secure and clean connections is vital in preventing intermittent issues from arising, as this can save significant time and effort in future diagnostics. This determination serves as an essential checkpoint for further troubleshooting procedures. In this sixth step, it is important to turn the ignition switch to the lock, 0 position before proceeding. This step is crucial to ensure safety while working on the vehicle's electrical systems. Once the ignition is off, disconnect the VTC oil control solenoid valve 2P connector. This action allows for direct testing of the solenoid valve without interference from electrical signals from the ECM. By doing so, technicians can perform measurements and inspections more accurately. Proper disconnection of electrical connectors is vital to prevent accidental shorts or damage to the terminals or wiring. These foundational actions prepare the technician for subsequent steps that involve measuring resistance and continuity. The seventh step requires measuring the resistance between terminal number 1 and terminal number 2 of the VTC oil control solenoid valve 2P connector. This measurement is critical for determining whether the solenoid is functioning properly. The acceptable resistance range should fall between 6.75 ohms and 8.25 ohms at room temperature. If the resistance within that range is confirmed, it indicates that the solenoid has acceptable electrical characteristics. However, if the resistance does not meet this specification, further troubleshooting will be necessary, as it may indicate that the solenoid is faulty or that there is an issue with the electrical circuit supplying the solenoid. Understanding how to properly measure electrical resistance is essential for diagnosing electrical components effectively. In this 8th step, technicians will check for continuity between terminal number 1 of the VTC oil control solenoid valve 2P connector and the body ground. Establishing continuity is important to determine whether the electrical path to the ground is intact. A good connection will indicate that there are no breaks or interruptions that could affect the solenoid's operation. If continuity exists, this helps validate that the electrical system is functioning correctly. Conversely, if there is no continuity, it indicates a possible open circuit in the wiring between the solenoid and ground, requiring repairs to ensure a solid electrical connection. Proper ground connections are vital for the solenoid to perform its functions reliably, emphasizing the importance of this troubleshooting step. The 9th troubleshooting step involves jumping the SCS line using the Honda Diagnostic System, HDS. The SCS line, or Service Check Signal Line, allows technicians to perform specific diagnostic tests and functions within the system. Jumping this line prepares the system for the next stages of troubleshooting by bypassing certain safety measures, thereby allowing technicians to check for stored codes and functionality of the system. After performing this jump, the technician should disconnect the ECM connector C, which has a 44-pin configuration. Disconnecting this connector allows for isolated testing of the electronic control module and its connections, laying the groundwork for in-depth diagnostics of potential problems. Understanding the relationship between the SCS line and the diagnostic tools is crucial for efficient troubleshooting. After completing all necessary repairs related to DTC P0010, it is essential to perform a final verification step using the Honda Diagnostic System HDS. This final check ensures that all issues related to the VTC system have been addressed and that the solenoid and its associated components are functioning as intended. By checking for new DTCs after repairs, technicians can validate the effectiveness of their work and confirm that no additional issues are present. If the HDS does not indicate any new fault codes, it suggests that the systems are operating normally. This process is vital for ensuring that the vehicle's performance has returned to optimal levels, further improving reliability and overall driving experience. Verification steps empower technicians to ensure that they have resolved the root cause of the problem and not just treated the symptoms. Preventive maintenance is vital for ensuring the longevity and effectiveness of the VTC system, thereby avoiding the recurrence of DTC P0010. Technicians should regularly inspect components related to the VTC system, including the oil control solenoid valve, wiring connectors, and associated harnesses. Such inspections can uncover early signs of wear or damage that may lead to future issues. Additionally, regular checks of the engine oil conditions are essential, ensuring that the oil is clean, at the proper viscosity, and free of contaminants. This is significant, since old or contaminated oil can adversely affect the performance of the VTC system and its components. Implementing a preventive maintenance schedule helps identify problems before they escalate and ensures that the vehicle remains in good working condition. In summary, understanding and addressing DTC P0010 regarding the VTC oil control solenoid valve malfunction is vital for maintaining the performance of the Honda Civic 2006 to 2011 models. Timely diagnosis and repair are paramount to prevent engine performance issues, reduced fuel efficiency, and increased emissions. By systematically applying the troubleshooting steps from verifying freeze data to confirming repairs with the HDS, technicians can ensure a comprehensive approach to resolving the issue. Regular preventive maintenance further empowers vehicle owners to stay ahead of potential problems, ensuring the vehicle operates at its best. Effective management of this DTC can lead to improved reliability and functionality of the engine, contributing positively to the overall driving experience. Please like and subscribe to the channel. See you next